this very important webinar on a subject which is the core of occupational health, that is biomarker health. Without biomarkers, it won't be possible to understand the risks that every occupational health practitioner or occupational health researcher engages in. These biomarkers help in understanding the relative importance of various risks that individuals are put across, and also it gives you uh, the the measure with which one could compare various risks. Also, it is important to understand that this gives the basis on which our intervention strategies are based. Also, biomarkers in occupational health are important because when we measure the effect of the interventions, we would need the baseline data, and then we can compare the benefit that accrue as a result of the interventions. Now, this webinar has a very good quality of subject experts, Professor Barbara Harding, Professor Dr. Roberto Lucchini, and uh, from diverse backgrounds, from Italy, from US and Peru. And I must compliment Dr. Norville to make all the effort to organize this webinar on this very important topic. The International Commission on Occupational Health, along with the Scientific Committee on Epidemiology in Occupational Health, together would be holding similar webinars in future as well, which are important to the all the audience all the success, and I'm for all the participants who have spared their time to understand this important area. Thank you again, and successful webinar. I would be interested in knowing with the participants engaged in the subject. Thank you so much.
Thank you, Dr. Rajiv. It is a pleasure to have you here representing EPICO. Thank you for your words and for encouraging us to continue working on our preparation on topics just like this. So now I will introduce you to Dr. Barbara Harding, who is an assistant professor in the College of Population Health at the University of New Mexico and an associated researcher at the Barcelona Institute for Global Health. Her background is in epidemiology. Her research focuses on cardiovascular health and circadian disruption. She has conducted mechanistic and biomarker work among night shift populations that has been integral in establishing mechanistic evidence linking night shift work to chronic diseases outcomes. She also examines artificial light at night and its role in human health. Besides her research, she is also very active in encouraging and supporting early career researchers and has devoted time to several early career researcher initiatives, including most recently organizing the EPICO Early Conference in November 2024, which was held in Barcelona, Spain, where I had the great opportunity to be part of Dr. Barbara's team. So welcome, Dr. Barbara.
Thanks, Norville. Can you give me permission to share my screen?
Yes. Now you are the host.
Yep, perfect. Now. Okay. Bueno, hola a todos. Voy a dar la presentación en inglés, pero después, durante la parte de pregunta y respuesta, me puedes preguntar en español o inglés. So thank you for the invitation to speak today, Norville. I'm going to be focusing on integrating biomarkers into studies of occupational health with a particular focus on experiences in night shift working populations. So by way of a little bit of an introduction, I wanted to spend a little bit of time talking about circadian rhythms. These are found throughout nature, obviously in humans, but also in plants and animals. And this is it's a daily biologic rhythm that regulates countless behaviors, different biological processes, and so much more. And to give you guys a little bit more of an example, just some specific areas where we see circadian rhythms at play. Again, these are throughout our whole body. We have body temperature. So body temperature typically is lowest during the nighttime and rises during the daytime, the biologic day. We also see hormones. There are two plotted here. In this photo, you can see melatonin and cortisol. Melatonin typically peaks when we are peak sleepiness and then goes down during the day when we're a little bit of a different rhythm where it peaks right upon awakening. So we have a cortisol awakening response. We also see circadian rhythms regulating countless different immune parameters. So there are multiple shown here, and we see this in gene expression. But again, we see this throughout the body and metabolomic processes and so on and so forth. And so, as I mentioned, these are daily rhythms. So they follow a roughly 24-hour cycle. And the main synchronizer of the circadian system is the natural light and dark cycle. So the way that this works is shown nicely with the figure here, where light enters your eyes. It actually is interacting most strongly with these iPRGC cells, and it sends off a cascade of different processes after that. So we have this master clock that's located in the suprachiasmatic nuclei in the brain. But in addition to that, that's regulated most directly by light, we have peripheral clocks that are present in countless areas and tissues throughout the body. And an issue here, related to night shift work, which is why I'm giving this talk, is that night shift workers, because they are awake during the biologic night and they are sleeping at some point during the biologic day, they experience circadian misalignment. And so we know that shift work is related to a variety of different chronic diseases, but the mechanisms are still unclear. So I'm going to give a couple of different studies. I'll talk through what we've been doing and have achieved so that you guys can kind of see what we've been doing to try to measure circadian rhythms and to try to produce biomarker-based evidence linking night shift work to different chronic disease changes in the body. So first, we'll talk through the Hormonite study. This study has completed. We completed this study now several years ago. And it included 51 adult male rotating night shift workers from a car factory in Spain. And I'll talk through more of these methods in a little bit, but we focus mainly here on investigating hormones, immune markers, including cytokines, and also metabolomic markers. And then the second study that I'll mention today is the E4 study. So this is a larger exosome European study. Within that, one work package focused on a night shift exosome study. And so here we had a total of 966, both male and female, night and day shift workers. The day shift workers here were our reference group from multiple countries. And we focused on a wider set of mechanisms. So we replicated, or we aimed to replicate, the findings that we found from the smaller Hormonite study, but we also collected a much wider variety of biomarkers as well. And before talking about each of these two studies, I wanted to pause and talk about why circadian rhythms are important and how they implicate our collection methods when we're doing biomarker work. So the timing of samples is very important because, as we saw, these, let's take melatonin, for instance, it goes through this really nice cycle where it's very high when we're sleepy and it's low overnight. So depending on when we sample melatonin, if we just sample once, we won't get the full picture. We won't really know what's going on with melatonin. We'll just have a snapshot. So, both the timing of when you take them and trying to get multiple samples so that you can rebuild this the whole cycle is very useful. It's also ideal to have information on the individual circadian phase, their general circadian phase that's kind of underlying things, so that you can assess how misaligned they might be with a given peripheral rhythm, for instance. And then also in this area, it's very useful to have additional information such as the different regulators of the circadian rhythm, like light, diet timing, activity timing, and sleep-wake timing, and also useful to collect information on chronotype. So let's get back to the Harmony study. As I mentioned, this was 51 adult males from a car industry in Barcelona, Spain. They were rotating shift workers. They actually worked in a backwards or counterclockwise rotating schedule. And that's presented here. So they worked 3 weeks during a night shift. They then had 3 weeks of an evening shift and 3 weeks of a day shift. They always had the weekends free, so no work here. But then their hours are shown in this table. I've also shown in red here. So we sampled these individuals twice, and they served as their own control. We took one sample when they were in their second or third week of their night shift, and we took another sample when they were in their second or third week of the day shift. The rationale being we wanted them to be adjusted in some way to their shift rather than just sampling them right after they had begun their next rotation. In terms of the data collection, so in both shifts shown side by side here, we used a very similar method. At the start of the shift, participants responded to questionnaires and they also gave a blood sample. When they finished their shift, they gave a second blood sample. And then during the 24 hours, so when they came in for their day shift on Tuesday until when they came in for their day shift on Wednesday, they collected all urine voids. So throughout the 24-hour day, we had all of their urine collected. They also wore this hobo sensor that you can see, this green sensor here, to get light information. And they wore an actigraphy device so we could get sleep and activity patterns. I've shown encircled here the urine samples because that is what we use for the hormone analyses, which I'll talk through in just a slide. And then I'm also highlighting here these 2 blood samples in particular. Yes, we collected 4 samples in total, but we mainly focused on these 2 blood samples because they were both collected at the same clock time. So the start of the day shift was at 6 a.m. and the end of the night shift was at 6 a.m. Obviously, they've had different exposures during those times. Some people are coming off of being awake for several hours, whereas the day shift folks are probably just kind of coming in to work after maybe having an early breakfast at home. But these happen at exactly the same clock time, and so we can really assess what's going on with their circadian rhythms if things are very perturbed, much lower, much higher, so on and so forth. This is some demographics. So quickly, our participants, again, all males, were roughly 38 years of age. The majority of them fell into this BMI of, overweight or obese categories. As is common of the Spanish population, we had almost 40% that was current smokers. This is actually a little bit higher, but it's not shocking for kind of a car factory working population. We also had participants, they were not new. All right, it sounds like someone might have their microphone open, so maybe you could mute. We also had these participants working for several years in night shifts. So on average, they've been working in night shifts for 10 years. For the hormone analyses, as I said, we had their urine collected throughout the day in different urine voids that were time-stamped. And we were able to then put these together. We plotted, maybe this is one sample here, maybe they had another sample here, and so on and so forth throughout the day. And then we use what's called cosigner analysis to fit the values to a cosigner curve and pull out some key values. So one was, what is the peak? What is the absolute maximum production? At that time, it's called the Acker phase. So that's the time of peak production. We also could assess the area under the curve to give us a sense of the total production of that particular hormone. And then we can see, some other characteristics as well. But for the purposes of what I'll present shortly, we cared about the time of peak production as well as the total production. And we use linear mixed models to compare different values between the night shift sample to the referent day shift sample. Again, these are the same participant. We're kind of comparing them to themselves. And then I also wanted to show you guys some of the results from the immune marker analyses we did with these participants. For here, the methods we use a panel that included 30 different cytokines, chemokines, and growth factors. We measured these in all 4 of those blood samples, but we really focused in on those 2 times that were both at 6 a.m. So the start of the day shift, the end of the night shift. We use Luminex technology here, and we again use linear mixed models so we could compare the differences between folks during their night shift versus their day shift. So shown here, this is the acrophase at time of peak production, and you can see, these values are coming up towards the right-hand side of this figure, which is suggesting that during the night shift, the acrophase was delayed in some cases by many hours compared to the peak time during the day shift. You can see that there's, a noticeable delay of melatonin up at the top, but we also see delays of many different androgens and so on and so forth. In terms of hormone production, we are seeing some differences here. We see a lot of things that are, falling either left or right of that line, but we had 2 specific hormones shown here. We had one androgen and also a progestogen that were statistically significantly, both the first was overproduced and the second was underproduced. So we're seeing from our hormone-specific analyses that we have lots of changes in terms of timing, and we also have some changes in terms of total production. And in working with the folks in our group that specialize in hormone-related information, this helped us to understand what the mechanism might link night shift work to some hormone-dependent cancers, for instance. And so this is kind of some of the missing evidence that might explain why night shift workers generally have more prostate cancer, or night shift workers may have more breast cancer. And we published these findings in this reference shown here. For cytokines, we saw that the cytokines now, they're on the left-hand side of this graph here. So during the night shift, they were underproduced in comparison to the day shift values. And to orient you a little bit more, the top of this graph shows some pro-inflammatory, then we have several anti-inflammatory, different TH types. Chemokines come towards the bottom half, and then growth factors at the very bottom. We're seeing, again, the general trend of underproduction. And from what we included in this panel, the majority of the cytokines and chemokines that were lower, that were statistically significantly lower, were more pro-inflammatory in nature. So this, again, working with the immune specialists in our group, we determined that we had enough evidence here that indicated a dampened immune response. And obviously the immune system has so much overlap and interplay in lots of different chronic disease mechanisms. So this is very useful information. And this, again, we have published this in the reference shown here. I'm not going to share the metabolomic stuff just for the sake of time for today, but we also saw a lot of perturbations with the metabolomics within the night shift workers in the HormoneEat study. So I'll shift the focus now to the E4 project. Again, this is a larger effort with lots of different work packages, and I was working in one that was focused specifically on the night shift exposome. And here we had lots of aims with this study. We wanted to, replicate our findings from HormoneEat, but we wanted to really increase the sample size. So we had only 51 in HormoneEat. We wanted to have a lot more folks here. We also wanted to try to increase the generalizability, so not just focusing on one specific location of night shift workers in one country, but include other countries as well, where there may be different influences. And we also here tried to have a mix of both females and males. So let's go over what we have from this E4 population. We have participants from 4 different countries: Spain, Sweden, Denmark, and the Netherlands. We tried to have a nice mix of men and women, but based off of we had a lot more healthcare workers than we originally planned for, and a lot of the healthcare workers ended up being, more professions where there's a larger female workforce. So we had close to 90% were females. Again, as mentioned here, we had mostly healthcare workers, but we also had some contribution from bus drivers within the Spanish cohort. And we are currently working on our first publications here, so I'll mention some of our preliminary findings, but I'll more focus on, what our major plans are and how we've incorporated biomarkers into this study as well. As I mentioned, this is an exposome study, so we really also undertook the effort to try to get a lot of information, try to add in some information on kind of prior exposures as well to add to this kind of life course, which is also within the exposome approach. But we used a variety of techniques to collect data. So we had baseline questionnaires. We took anthropomorphic measurements in person, so height and weight, also waist and hip circumference and blood pressure. The participants responded multiple exams. They also use an ecological momentary app that they downloaded on their phone. And so they responded to short questionnaires every day to give us kind of more real-time information on lifestyle habits and daily patterns. There were a variety of sensors to help us collect light, as shown here, heart rate information, movement and sleep. We also had them with this sensor box that did like PM collection, noise collection. So we had a lot of sensor-based measurement here. And then we sampled several biomarkers. So we took blood, we took saliva. I should say, unfortunately, we only took one blood sample because of the additional complexity of the study. But we did collect saliva over the course of an entire day. So we can have, again, the information on hormones, that really nice solution, and see how this curve changes. And we also had a subset that collected stool so that we could analyze the gut microbiome. Main objectives here were really to focus on how night shift work relates to chronic disease outcomes, so cardiometabolic, also mental health and cognitive related, and also aging related outcomes. Again, we really wanted to focus on these biomarkers. That's why we took many different kind of samples. And here I've really highlighted the different biomarkers that we're measuring. So just like the hormone study, we're again focusing on immune markers, hormones, and metabolomics. We also now, with an E4, are measuring proteomics. We've done some microRNA collection. We're looking at the microbiome, as I mentioned, the gut microbiome. We're looking at telomere length as an aging-related marker, mitochondrial DNA count number, GWAS, and EWAS. So quite a variety. And a little bit more so you can visualize this data collection overview. We had participants doing this really intensive data collection over 5 days. So we had, more of a complete picture was the hope. This included wearing sensors every single day, answering that app every single day, and then we did some other measurements throughout the days. Generally, the questionnaire was actually responded to in the week prior to this intensive data collection, so there was one less thing to do. But we took the blood on one day along with anthropomorphic measurements. We had saliva collected on one day, but again, the whole day they had 5 different collection time points throughout the day. We took the stool on one day, and then the cognitive exams were broken up into 2 different days because we measured kind of both an emotional related aspect of cognition, and we did your basic cognitive stuff. And the basic cognition we wanted to get on a day when they had a free day away from work. So we are seeing now, this is actually in my second bullet point. We're seeing now some preliminary findings specific to the cardiometabolic outcomes that are showing differences in blood pressure, in heart rate, and in waist-hip ratio and kind of abdominal obesity markers among night shift workers. And these are particularly pronounced among the female group. We have seen from both Hormonite, and now we're also seeing in our preliminary findings from E4 that circadian disruption as a result of night shift work results in perturbed biomarkers, and this provides some important mechanistic evidence that we haven't really had a lot of to date in the literature. Despite mounting evidence of the health risks associated with night shift work, we still have some gaps to address. So we need to focus more on this interplay of occupational exposures. That's why the exposome approach is important and useful. We also need to understand kind of individual susceptibility. And then, we've had night shift work evaluated twice now by IARC. It's probably carcinogenic based off of both of these evaluations, but we really do have mounting evidence on its links to cancer, and hopefully some of the mechanistic evidence that we're uncovering from our investigations will hope to move that evaluation forward. And then we have some other areas where we need to do more. So we need to not just focus on night shift, yes or no. We need to really focus on the duration of night shift work. How many night shifts are they working back to back? How many night shifts they work on average during a month? Some of these things that get more at dose response would be really useful. And we've also had a lot of people ask us questions about, hey, I worked night shifts 10 years ago, but I don't anymore. Do I have any lingering effects? So I think that is also another useful question to try to address. I wanted to acknowledge my team from ICE Global that worked on Harmonite, and also the larger group at ICE Global and elsewhere that are working with E4. And I'd love to take questions.
Thank you, Dr. Barbara, for such a great presentation and sharing with us your experiences and research. So we would like to invite attendees to make some questions. Even Dr. Barbara conducted this presentation in English. She lived in Barcelona, so she also speaks Spanish. So maybe if you want to make questions in Spanish, probably Dr. Barbara will be fine with that. Or if not, we can help you, Dr. Barbara, with the questions. So please. Or maybe you can write your question in the chat too, so we can read the question to Dr. Barbara. If you consider you can write a question in Spanish and we can help you with the translation with to Dr. Barbara.
Bueno, si no, yo puedo responder a las preguntas durante la próxima presentación. Normal.
Okay.
Hay preguntas por el chat.
Doctora, una pregunta.
Ajá.
Digamos, ¿qué perspectiva para empezar a medir estos biomarcadores ya como en la práctica con los trabajadores? No sé, por ejemplo, cortisol o hormona de crecimiento. No sé si hay como una aplicación en el futuro próximo, pues de un biomarcador que pueda ser utilizado a gran escala.
Sí, por ejemplo, los hormonos que son más utilizados son melatonina y cortisol. Realmente son muy fáciles para medir estos. Tú puedes hacerlo usando orina, como en el estudio de Hormonite, pero también usando saliva es súper fácil. O sea que es un tubo de plástico que tú puedes poner un poco de saliva y es muy estable si pones esto dentro de la nevera. Am, no sé, otro tipo de tecnología donde puedes medir las hormonas muy rápido, pero de saliva es muy, muy útil medirlos en saliva y es muy fácil medir mucho desde una muestra de saliva. No sé si he respondido bien a tu pregunta o si tienes algo más.
Sí, doctora, muchas gracias.
Okay, yeah.
Gracias, doctor.
Barbara, if I can ask you a question in English, I mean,
Sure.
I can ask you in
It's
Español.
okay. Also, Kurt asked me to say hello to you. Actually, we've never met.
Hi, Barbara. Nice to meet you.
You too.
By the way, I live in Miami, entonces hablo español más que inglés, pero let me ask you in English. I just have a simple question, Barbara, because all these changes, night shift versus day shift, I guess that this is all physiology, right? Because people normally have to adapt to night and day. So, and all these changes in hormones, etc., and biomarkers, I guess that they reflect basically physiological adaptation. But the question is, how can you understand when and how this becomes something that is not physiological anymore and becomes something more related to potential, disease or alteration?
Yeah, thanks for the question. I don't know if I can respond to it super concisely, but
Sorry.
I think
It's a
the ideal
curiosity.
Yeah, no, we've talked about this a lot. I think the ideal scenario is that we have both a sense of kind of acute changes, like you're mentioning, like they're just adapting to their shift versus longer term changes, So if we're able to really assess, what is the impact of working in night shifts for a year versus, they work in night shifts. They've been doing night shifts. They've been waking up at weird times for the past 3 days in a row. Obviously they've kind of adapted in some way. And I think that the question of adaptation is also challenging and, you know, really depends on what your schedule is. If you're, a permanent night shift worker, it's probably better that you don't really adapt back to days, that you just kind of stay on that schedule and it's better for your whole system. So adaptation, I think, is both good and also bad, depending on how much you're shifting back and forth. Are you constantly, pulling yourself one way or the other? Um, and again, yeah, I think we haven't had a good sense of what are the lasting impacts versus what is like an acute change that's really normal and might just signal adaptation, which is kind of healthy and usual.
Thank you. Thank you, Dr. Roberto and Dr. Barbara. We have another question in the chat. Uh, which are the confusing variables that you had to control on those researchers?
Yeah, so es un poco diferente en el estudio de Hormonit porque tenemos la misma persona, o sea que estamos usando persona uno para comparar con persona uno durante la noche. O sea que solo tenemos aquí de usar cosas como luz, por ejemplo, o hemos puesto dentro del modelo días que han pasado de entre la muestra uno entre la muestra 2, pero además no vamos a controlar para edad, por ejemplo, es la misma persona, o no vamos a poner el sexo porque es la misma persona y todos eran um, masculinos. En el estudio de E4 vamos a utilizar más cosas como por ejemplo centro, porque tenemos 4 países, edad, sexo, educación, más cosas normales que son normal para usar en los análisis.
Is there any other? Oh, there's another question from Dr. Bruna Cuadros.
Do you want me to
Very
do,
interesting.
okay. Let me know if we need to
Please.
go to the next one. But yeah, so this is a nice question. We think that it's the best thing that we can do here is to provide people with enough time to rest after they have night shifts so that they can, relax and recover. Since this is really, but we also have information to suggest. So the opposite of what I just showed you is healthier. So working from, if you're going to be a rotating worker, you work in days and then you work in afternoons or evenings and then you work in nights. That's more of a natural way to progress your rhythm versus working day and then working night and then working evening is counterintuitive and is harder for people to adapt to. So some of those things are, useful to know. And also generally faster rotations are easier to manage rather than working in a rotation for a very long time and then moving because you really have adapted very well to that rotation. Norval, I can keep responding to questions if they come up in the chat if you want to move to the next person.
Oh, I'm just admitting the new people. Is there any other question, please? Is there any other question in the chat? Oh, there's a question from Indira. You may reply, Barbara, please. It says that se hizo algún estudio con trabajadores con alguna enfermedad metabólica. Did you consider any metabolic disease? y que se haya registrado el cambio en sus biomarcadores y cómo afecta el turno nocturno en su control. And if you register the changes in the biomarkers and how the shift work affected in their monitoring.
Yeah, we've never done anything special among, people that have kind of pre-existing metabolic disease. We've just used like a mixed group. Um, we are, though, there's a part of the E4 study just within the Swedish center. They use like continuous glucose monitoring and they've taken fat biopsies. So they are really focusing on getting more information about how night shift work relates to, this metabolic type aspect of changes. Um, but yeah, this sounds more like, if we started with a group of people that had metabolic disease and we've kind of tried to change things. So in Dira, we haven't really done this exact thing.
Finally, I would also like to make a question, Dr. Barbara. It was a very interesting what you mentioned about the cytokines and our immune system. So, do you have any, maybe you can share some results or experience about during the COVID-19 pandemic and how the shift workers were affected?
Yeah, so I haven't done any of this work exactly myself, but one of my collaborators is working on doing some kind of vaccine response. And we know that there's difference in vaccine response based off of if you get the vaccine early in the morning versus later in the day, those types of things because of the way your circadian rhythms work in the immune system and when it's more active. And there has also been some work published on how night shift work relates to less effectiveness of vaccines. I think, it all relates to the circadian rhythm aspect of the immune system. Um, I think night shift workers also generally happen to be kind of more frontline workers that were just, more exposed by nature of them working as a healthcare worker, for instance, or doing kind of necessary tasks during the COVID pandemic when a lot of us could just work from home. So we saw quite a bit of infection among night shift workers. But yes, there's absolutely information about kind of vaccine effectiveness and different disease susceptibility that I think acts through this immune perturbation system.
Thank you. So, well, thank you, Dr. Barbara, for your presentation, for sharing your research with us and replying very actively all the questions from the attendees. It was really nice to have you here. Um, Now, I would like to introduce you to Dr. Aldo Caguana Vasquez from Peru, who is graduated from the Alberto Hurtado Faculty of Human Medicine of the University Cayetano Heredia, who has an specialization in occupational medicine at Federal University of Rio Grande do Sul in Brazil, in applied toxicology at the Pontifical Catholic University of Rio Grande do Sul in Brazil, and then a specialization in occupational hygiene at the University of Sao Paulo, Brazil. He also has a master's degree in health administration at ESAN, Peru. He is currently a professor of occupational and environmental medicine at program at University Peruana Cayetano Heredia, and also is professor of occupational health management at University ESAN of Peru. So welcome, Dr. Aldo Caguana.
Thank you, Norville. I thank you for your invitation. I prepared this presentation in Spanish. ¿Me puedes dar el control, por favor, Norville, para presentar?
Sí, sí, sí.
Ok. Bueno, muchas gracias, Norville, por la invitación. El encargo que tengo es hablar acerca los biomarcadores utilizados en programas de vigilancia médica en trabajadores expuestos a riesgo químico y compartir un poco la experiencia que tenemos en la industria química, ¿no? Realmente es un desafío. Es un desafío porque hay muchas falencias en los conceptos que se manejan, ¿no? Hay interpretaciones inadecuadas acerca de lo que es una exposición, acerca de lo que es un biomarcador de efecto, acerca de un biomarcador de susceptibilidad y cómo podemos aplicar esto para hacer nuestra vigilancia de forma adecuada y oportuna. Entonces, ¿cuál es el marco en que nos manejamos? ¿Qué es un biomarcador? Un biomarcador es una alteración de un componente, proceso, estructura o función celular que lo vamos a obtener de un sistema biológico o una muestra. Y acá viene una parte muy relevante, que esto no necesariamente significa una enfermedad. Si estamos trabajando en el mundo de la salud ocupacional, nuestra primera etapa es de prevención. Y en esa primera etapa de prevención vamos a manejar biomarcadores que pueden ser de exposición, de efecto o de susceptibilidad. Lógicamente, en una etapa posterior, en una etapa donde ya encontramos alteraciones, presencia de sintomatología clínica, van a haber otro tipo de marcadores u otro tipo de valores que nos van a permitir diagnosticar o establecer una enfermedad. Pero en la etapa primaria, en la etapa que nos interesa, estamos hablando de alteraciones tempranas, idealmente reversibles y que no generen un daño, ¿no? Entonces, un biomarcador abarca este concepto. Y, y la idea es que establezcamos, identificamos o busquemos esta gestión en base a una respuesta celular precoz. Significa que yo voy a buscar una alteración temprana y ese es el gran desafío. Hay algunas cosas definidas, la gran mayoría de exposiciones a sustancias químicas no tenemos esto definido. En la gran mayoría de exposiciones hablamos de múltiples sustancias químicas, algunas en altos valores, otros en bajos valores, y el impacto no lo tenemos claro. Entonces, ese es nuestro desafío que siempre establezco, ¿no? ¿Cómo sabemos en forma temprana que está habiendo un impacto en la salud del trabajador? Y ese es el gran desafío que tenemos los médicos que trabajamos en la industria química. El biomarcador nos va a ayudar para la evaluación de riesgo, reitero, nos va a ayudar para la evaluación de riesgo, no solamente para el diagnóstico de una enfermedad. Tenemos que establecer cuál es el impacto de la gestión que estamos haciendo en la empresa, cuál es el impacto de ese control de los riesgos que estamos teniendo. Nos ayuda para el tema de riesgo, nos ayuda para establecer relaciones dosis-respuestas. Esto lo hacemos en empresas donde tenemos múltiples sites y tenemos una población importante, ¿no? Entonces ahí sí podemos, con el soporte adecuado del equipo médico, podemos establecer este tipo de controles, de estudios. También nos permite identificar riesgos a largo plazo por la exposición a sustancias tóxicas. Y acá también tenemos un papel relevante. ¿Por qué? Porque en función a la data que tenemos de exposición, en función a la data de historia clínica o de impacto a la salud que podamos documentar de forma adecuada, a largo plazo vamos a poder contribuir a establecer algún nexo ocupacional con estos impactos a la salud. También, y esto también es importante en nuestro quehacer, es identificar marcadores tempranos de toxicidad en el campo de la ecotoxicología. No solamente nos preocupamos por la salud de los trabajadores. No solamente nos preocupamos por la salud de las comunidades aledañas, también es importante observar cuál es el impacto a los ecosistemas en el cual se desarrollan estas actividades, ¿no? Y ha habido experiencias que hemos compartido con algunas empresas en Ecuador, por ejemplo, de minería de oro, que hemos visto cómo podemos identificar o establecer programas para monitorear estos impactos en el ecosistema, sobre todo en actividades que están en zona de selva, se ha dado la experiencia. Y el gran desafío que vamos a tener es este, ¿no? Determinar cómo es la exposición, ¿no? Sabemos cómo es la exposición rutinaria y no rutinaria, sabemos que las exposiciones son variables en el tiempo, y por otro lado es conocer a nuestros trabajadores. Y dentro de este grupo de trabajadores, conocer qué trabajadores son más susceptibles a este tipo de problemas. Sabemos que va a haber trabajadores que tienen una susceptibilidad que puede ser adquirida. De repente yo desarrollo un problema hepático por estilos de vida, por consumo de alcohol, y este problema hepático me hace menos eficiente en el metabolismo del químico. Eso lo voy a tener que vigilar a lo largo del tiempo que estoy cuidando al trabajador. Pero también existe, y eso de repente es un poco más fino, es susceptibilidades que son inherentes al trabajador, ¿no? De repente, en muy pocos casos, de verdad, de la experiencia que yo tengo, hemos logrado establecer esto. Es decir, cuando hay situaciones atípicas, presencia de sintomatología que no cuadra con los valores que manejamos en el tema de exposición, planteamos que puede ser un tema de susceptibilidad y en muy contados casos se ha podido verificar que hay una deficiencia de algunas enzimas, ¿no? Pero el desafío que tenemos es eso, ver cómo la exposición, ver en qué momentos puede haber una exposición atípica y por otro lado ver a nuestros trabajadores y ver qué susceptibilidades existen que los pueden hacer más sensibles a presentar un evento de salud. ¿Qué tipo de biomarcadores vamos a dejar? La exposición. Ese es el primer grande elemento que manejamos, ¿no? Los indicadores biológicos de exposición. Concepto fundamental ahí es que nos habla de exposición, no de enfermedad. Hay que ser muy claros en eso. Hay mucha mala interpretación en este sentido. Un trabajador excede el valor de exposición y automáticamente lo clasifican como enfermedad. No, hay que conocer estos conceptos, ¿no? Otra cosa que es interesante de este biomarcador es que nos ayuda a valorar la presencia de otras posibles fuentes de exposición. Claro, lógicamente la principal fuente que en la mayoría de casos vamos a manejar posiblemente sea la vía respiratoria, pero no desconozcamos la vía a través la vía dérmica o la vía digestiva. En determinados tipos de industrias, bajo determinadas condiciones, la vía digestiva puede ser un elemento importante, ¿no? Sobre todo en industrias donde las situaciones de consumo de alimentos, del cuidado al personal es bastante descuidada, como ejemplo minería ilegal, ¿no? También entendemos que los indicadores biológicos de exposición nos permiten comprender mejor cómo se está dando la exposición en el campo. ¿Qué significa esto? Muchas veces podemos tener valores de campo que nos indican que todo está controlado, pero hay sintomatología. Y esto podemos hacer la vigilancia con el tema de indicadores biológicos de exposición y comprender mejor qué está pasando en ese campo, ¿no? Ejemplos clásicos, plomo en sangre. Plomo en sangre, por lo menos de la parte de Sudamérica que estamos, la industria minera es por excelencia la principal, donde el mejor ejemplo que podemos plantear es exposición a plomo y voy a hacer plomo en sangre. Voy a monitorear eso como un indicador biológico de exposición en esta etapa que estamos hablando de exposición, pero hay también plomo en sangre que nos permite hacer valores de diagnóstico de enfermedad, ¿no? Este es como un ejemplo, pero también tenemos los biomarcadores de efecto. Acá lo que nos indica es que hay una alteración temprana de alguna función. Una alteración temprana bioquímica puede ser una alteración temprana de una enzima, de la función de una enzima. Y usualmente estamos hablando, como digo, una alteración temprana y por lo tanto estamos queriendo valorar exposición. No estamos queriendo valorar efecto, ojo, no estamos queriendo ver efecto, sino queremos ver una alteración temprana que nos permite interpretar que está habiendo una exposición más allá de lo adecuado. Y acá el ejemplo por excelencia sería la exposición a órganos fosforados, ¿no? Donde, de acuerdo a la vigilancia que hacemos nosotros, hacemos la vigilancia con inhibición de acetilcolinesterasa, pero ese también nos puede servir para un diagnóstico de enfermedad, ¿no? Son diferentes etapas y conceptos que en la etapa de vigilancia que tenemos tienen que estar absolutamente claros. De ahí, algo más fino que podríamos manejar son los biomarcadores de susceptibilidad, ¿no? Donde podemos determinar que hay una susceptibilidad de la persona expuesta, en este caso de un trabajador, debido a que hay algunos procesos enzimáticos que no trabajan como deberían trabajar y por lo tanto exposiciones aparentemente aceptadas son peligrosas para este trabajador, ¿no? Esto es más raro, no es tan usual hacerlo en los trabajadores. Yo he visto algunos estudios donde se han hecho y en contadas situaciones de experiencia en las empresas se ha hecho, pero por sospecha para descarte de algún problema de falta de control en la industria, ¿no? Acá un ejemplo claro es el polimorfismo de sistemas activadores como el citocromo P450, una función enzimática que permite el metabolismo de muchas sustancias tóxicas en el cuerpo, ¿no? Entonces tenemos esta situación. Tenemos biomarcadores de exposición, son los más conocidos. Desde un punto de vista de higiene, son los indicadores biológicos de exposición. Esto lo podemos obtener muchas veces del requerimiento legal de cada país o de otros estándares como hay indicadores en Alemania, hay indicadores en Estados Unidos, en el ICOH. De ahí algunos otros son biomarcadores de efectos, esto ya son menos, en estos casos podríamos plantear algunos de ellos, aminasas si tenemos un basal, y a los biomarcadores de susceptibilidad que es menos frecuente, pero sí se puede plantear, habría que ver si existe la metodología adecuada en cada país para ejecutar, ¿no? Y esto es antes de presentar eventos de salud, ¿no? Esto de acá es vigilancia temprana. No estamos hablando de cuando ya hay sintomatología y hay presencia de algunas alteraciones en el screening en sangre, etcétera, ¿no? Que ya hacemos un diagnóstico más clásico. Entonces, lo que suele pasar en el médico que trabaja en industria química es cómo puedo hacer vigilancia de las sustancias químicas. No es fácil estudiar acá. Estamos hablando que hay que tener un conocimiento un poco más profundo de cómo se interactúa el cuerpo con la sustancia química. Cada sustancia química tiene una forma de interacción diferente, ¿no? La toxicocinética, la toxicodinámica es diferente y va a obligar a conocer esos procesos para entender cómo voy a vigilar. La otra cosa que es muy frecuente y típico, el tema de confusión, es qué tengo que muestrear, ¿no? Y eso sí abre un abanico de oportunidades. Eh, Hay mucha mala experiencia en el sentido de que se contrata estos servicios, el servicio desconoce el tema ocupacional y hace comparativos con valores ambientales o de población en general y genera un dolor de cabeza. Para esto es importante indicar que los indicadores biológicos de exposición hay estándares, hay definidos dónde se debe muestrear, cuándo se debe muestrear y sobre todo con qué valor vamos a comparar. Eso es importante, ¿no? Entonces, ¿qué es lo que vemos? Está viendo, por lo menos en esta parte de Sudamérica, un mayor incremento en el uso de los indicadores, en los biomarcadores en la vigilancia de salud ocupacional. Está viendo una mala interpretación de estos resultados, ¿ya? En la interpretación del valor que obtenemos, está viendo una mala aplicación del momento de muestreo. Es típico que en muchas empresas tomen los biomarcadores al momento de la evaluación médica ocupacional y esta evaluación médica ocupacional, lógicamente, es a primera hora del día. Y no, y en algunos casos de algunas sustancias, típicamente un ejemplo claro es los solventes, si yo le tomo el indicador biológico de expresión a primera hora del día, va a salir cero, y eso no refleja la exposición. Hay que entender ese proceso. Cuando yo quiero establecer una forma de vigilar al trabajador, tengo que entender cómo se absorbe esa sustancia, cómo se metaboliza, cómo se elimina, también entender el efecto que hace la sustancia al trabajador para sobre eso yo entender qué cosa tengo que hacer para vigilar y sobre todo para protegerlo. Lo otro que también es importante indicar, que lamentablemente sabemos que en algunos países las normas difícilmente se actualizan, ¿no? En el caso de mi país, en Perú, hasta hace poco teníamos una norma de límites de exposición del 2005, ¿no? Se acaba de actualizar hace poco, pero hasta hace 2 años teníamos legalmente valores de hace más de casi 20 años atrás. Entonces, eso era complicado. Legalmente tú cumples, pero desde un punto de vista de conocimiento actual, de nuevos lineamientos, sabías que estaba expuesto el trabajador. Entonces, acá es importante entender eso. La ley es lo mínimo que debemos cumplir. Sí, ante esto hay que revisar los nuevos estándares y ser exigentes con eso. Ser exigentes con eso. Nuestra misión es proteger la salud de los trabajadores. Entonces, hacer biomarcadores en la vigilancia médica es una parte de todo el proceso de comprender cómo es la exposición, de comprender cómo se comporta el trabajador, qué problemas de salud tiene, de comprender cómo son los controles, de comprender cuánto tiempo tiene el trabajador en la empresa, ¿no? Nosotros típicamente tenemos un histórico de historias ocupacionales, pero también nosotros tenemos un histórico de monitoreos de agentes químicos, lo cual nos permite hacer un cruce de información, ¿no? Esto evidentemente en empresas que nos permiten trabajar de esta manera, ¿no? Estamos hablando de empresas grandes con unos seguimientos corporativos un poco más sólidos. La realidad de las empresas pequeñas y medianas empresas es diferente, ¿no? Ahí toca aplicar otro tipo de metodología, Pero, como siempre digo, el conocimiento de saber cuál es el impacto de las sustancias químicas en los trabajadores lo podemos obtener de literatura, de fácil acceso. De repente, el desarrollo de monitoreos podemos tener alguna dificultad, pero medidas de prevención podemos empezar a implementar, ¿no? Todo es cuestión de comprometernos con la vigilancia que queremos hacer. Entonces, como ven acá, hay que comprender la toxicocinética. ¿Qué es la toxicocinética? Es lo que el organismo hace a la sustancia química, cómo ingresa, cómo se distribuye, cómo se metaboliza, cómo se elimina. Hay que comprender la toxicodinámica, que significa qué es lo que el agente químico hace al organismo, cuáles son los órganos blancos. Hay conceptos que hay que manejar como la dosis externa, como la dosis interna. Esto no es nada del otro mundo, porque cuando estás en una industria química, en los primeros años posiblemente sea complicado, pero de ahí tú ya vas reconociendo cuáles son las sustancias que con más frecuencia se utiliza, cuál es la más cantidad, la más peligrosa, y vas conociéndolo, y al final se enfoca en unas 5 o 10 sustancias, ¿no? Y es nuestra obligación profundizar en esos conceptos, profundizar cuáles son los efectos de la salud a corto, a largo plazo, profundizar en conceptos si son sensibilizantes, si son reprotóxicos, si son carcinogénicos. Podemos hacer eso, ¿no? Es nuestra obligación y estamos en plena capacidad de hacer eso. El acceso a información está, ¿no? No es difícil acceder a información, ¿ya? Eso existe, tanto en literatura como en páginas gubernamentales de algunos países de Europa. Pero entonces, los biomarcadores son parte de todo un proceso que hay que analizar y que estamos en la evaluación es para poder interpretarlos adecuadamente. Entonces, siempre que queramos usar biomarcadores tipo plomo, arsénico, cadmio, etcétera, la primera pregunta es si necesitamos un monitoreo biológico. Y este monitoreo biológico es parte de un proceso de higiene. No es coherente hacer un monitoreo biológico si no tenemos estudios de campo. ¿Qué significa esto? Yo no voy a dosar plomo en sangre si no sé cómo está la exposición de plomo en ambiente de trabajo. Claro, excepcionalmente por la sintomatología sospecho, por conocer el proceso sí, pero lo ideal es saber cómo está en campo la exposición, la dosis externa, para poder determinar la dosis interna, que vendría a ser el monitoreo biológico. Una vez que de acuerdo a la data que tengo, la data médica, de acuerdo a la data, establezco que es necesario ese monitoreo biológico, la pregunta es lo que decíamos, comprender a la sustancia química, con qué interactúa, se absorbe por qué vía, cómo se distribuye, interactúa con qué órgano, se elimina por qué ruta, tenemos que comprender y conocer esto. Pasado esto, nos toca revisar el histórico. En algunas empresas tenemos data donde los monitoreos ocupacionales los resultados son bajísimos, 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 realmente no llega al nivel de acción. Pero algo que es muy común es que tienes varias sustancias químicas a bajas concentraciones pero que afectan al mismo órgano, por ejemplo el hígado, y ese es un desafío a trabajar, ¿no? Pero bueno, analicemos la data de salud, de higiene, cómo se comporta y de ahí hay que establecer algo que también es muy recomendable, establecer las medidas de acción en función a los valores que podamos encontrar, ¿no? Es típico que algunas empresas, al ver que hay presencia de problemas, duden en implementar medidas. Esto se tiene que establecer antes y tiene que estar alineado con los liderazgos adecuados, ¿no? Y otra cosa fundamental, lo que hablábamos, el momento del monitoreo. Tenemos que participar o establecer en qué momento se tiene que tomar esa muestra, ¿no? El diseño de la estrategia de monitoreo. Es muy frecuente que esto se delegue a otras empresas y eso no es correcto. Tenemos que estar conscientes y somos responsables de establecer en qué momento se tiene que monitorear al trabajador. ¿Ya? Hay monitoreos que se pueden hacer independiente del tiempo, hay monitoreos que se pueden hacer al final de la jornada, hay monitoreos que se pueden hacer al final de la semana, al final de la jornada. Bueno, y de ahí la planificación de medidas de control y ya tenemos un programa de monitoreo y esto sencillamente hay que ejecutar. ¿Acaba esto acá? No, no acaba esto acá. Esto de acá tiene que ser, los resultados que tú obtienes, tienen que ser coherente con tus valores que tienes de tu data de salud. ¿no? Es decir, cómo está las aptitudes de tus trabajadores, cómo está la incidencia de problemas respiratorios, etcétera. Toca hacer una reevaluación y entramos en un ciclo de mejora continua, ¿no? Teóricamente, si es que tú haces una buena evaluación de riesgos y estás controlando bien los peligros y riesgos, no debería haber valores elevados de exposición. En cambio, muchas empresas mencionan que todo está controlado, pero tú monitorizas y ves que hay valores altos y probablemente hay una fuente no valorada o hay una vía de exposición que no ha sido la adecuada. Entonces, este proceso es continuo, ¿ya? Que vamos a tener que hacerlo siempre, siempre, siempre. Hay estrategias, hay técnicas que te definen con qué frecuencia podríamos hacer. Eso está en función a los resultados que tienes, está en función a cambios de procesos, está en función a los resultados que obtienes de la historia médica. Pero es una etapa interesante, ¿ya? Y evidentemente, como parte de cualquier sistema, esto se documenta, se comunica y se publica a las partes interesadas, ¿no? En líneas generales, hay que entender que hay que empezar a manejar estos conceptos. Lo primero que siempre recalco, conceptos claros. ¿Qué es un biomarcador? ¿Qué es un biomarcador de exposición, de efecto, de susceptibilidad? ¿Cuál es su interpretación? ¿Cuál es el requerimiento legal vigente? Y evidentemente, si ese requerimiento legal vigente calza con el conocimiento actual de los efectos de esa sustancia, ¿ya? Hay que conocer cuáles son los órganos blancos, a qué parte del cuerpo afecta, identificarlos y evidentemente plantear cómo voy a vigilar la salud de ese órgano que se puede afectar y conocer, cuando yo conozco la toxicocinética, es decir, cómo ingresa, cómo se metaboliza, cómo se elimina, cuidar esos órganos, ¿no? También es importante. Y ahí también en algunos casos podemos establecer la susceptibilidad, ¿no? Biomarcadores varios, ya va a depender del tipo de industria, va a depender del momento de exposición, va a depender de la mezcla de sustancias químicas. Es un desafío importante, pero es nuestra responsabilidad prestar atención a ello. Gracias, Norbert, gracias por la invitación. Quedo atento a cualquier duda o pregunta que haya. Muchas gracias.
Gracias, doctor Aldo. Gracias por su participación y por compartir también parte de su experiencia justo con nosotros. Eh, Sé que hay participantes de habla hispana y hay italianos y hay también de habla netamente inglesa, así que please, if you want to make any questions just in English or Italian or Spanish, please feel free to do it. Hay un comentario, doctor Aldo, respecto de la doctora Bruna Cuadros. Nos dice, resaltaste bien la importancia de que el médico no se limite solo a los valores legales, sino que emplee datos actualizados de la literatura. Gracias por eso. Lamentablemente todavía es necesario enfatizar lo que nos parece obvio. Entonces pregunta la doctora Bruna, perdón, de Brasil. ¿Cómo hacer un uso ético de los marcadores de susceptibilidad sin sesgar hacia una selección eugenésica?
Ah, Oi, doutora Bruna, muito obrigado. Prazer. Bueno, difícil, ¿no? Difícil. Generalmente acá tenemos un tema ético muy relevante, ¿ya? Como dije, de la experiencia que nosotros tenemos en la industria, lo hemos utilizado para poder diferenciar cuando teníamos presencia de sintomatología en personas que, de acuerdo a los valores de monitoreo que manejábamos, estaban protegidas o estaban en valores seguros, ¿no? No he tenido la experiencia que mencionas en una selección eugenésica, pero sí la decisión de tomar este tipo de estrategias de valoración de biomarcadores de susceptibilidad no es fácil. Eso es lo que yo podría comentar a la pregunta, Bruna. Muchas gracias por ello. Vale. Estudié en Porto Alegre, Bruna. Un placer.
Gracias, doctor. Gracias, doctora Bruna. Hay una participación
Sí,
también del doctor Ricardo
sí,
Alvarado.
Ricardo Alvarado. No, lo que pasa es que nuevamente ese es el tema, ¿no? si tenemos valores biomarcadores elevados por exposición, no aplicamos antídoto. Eso no se da. Y ojo, la aplicación de antídoto es muy delicado, es muy delicado. Uno aplica antídoto cuando son situaciones extremas y sobre todo cuando tienes el equipo de soporte necesario para afrontar cualquier eventualidad. No es un uso libre de dar antídotos. Si nosotros tenemos valores elevados, lo que se establece eran las medidas de control, ¿no? Puede ser el retiro de la exposición, estamos hablando un indicador biológico de exposición, lo vamos a retirar de la exposición, el tiempo va a depender del tiempo de vida media que se maneje con ese biomarcador, pero no, ahí no usamos antídoto, doctor Ricardo. ¿Ok, Norville?
Bien. Mm, Doctor,
Ricardo.
doctor Aldo, muchas gracias. Más bien se
Ok.
puede retornarme el host para poder facilitar el host al otro ponente y porque sé que hay gente que está en la lista de espera todavía para poder habilitarles el acceso.
Ok. Listo, doctor Norville. Thank you.
There are still nine participants in the waiting room, so I am admitting these nine. Please give me just 1 minute. I am admitting the new participants. Yo quisiera hacer una última pregunta, por favor, doctor Aldo. Ah, de su experiencia en Perú y en Latinoamérica, eh, ¿cuáles serían los principales sectores económicos donde aún no se utilizan los biomarcadores y que debido a la exposición laboral ameritaría no solamente que se inicie el uso de los mismos, sino que también haya intervención de parte del gobierno, por ejemplo, lo que nos mencionaba respecto a la legislación, donde se incluye el uso de los biomarcadores?
Es impresionante, Norville, porque realmente si uno empieza a investigar en cualquier tipo de industria, vamos a encontrar exposición a riesgos químicos. Desde que tenemos un área de limpieza, hay productos químicos y podríamos establecer en muchos casos biomarcadores. Y yo creo que el desafío que tenemos los que trabajamos en salud ocupacional, sobre todo en industria química, es profundizar estos conocimientos, ¿ya? Para poder implementarlos y sobre todo para valorarlos adecuadamente, ¿no? Sobre los gobiernos, bueno, es un desafío que tenemos, pero no es una limitante, porque como dije, el conocimiento actualizado está a disposición de todos. Eso, Navi. Muchísimas gracias.
Muchas gracias, Dr. Aldo. Thank you so much for your participation and sharing this great experience. And now we are moving to our last speaker. There's still more people in the waiting room, so I'm just admitting. Give me just some seconds to do it. Finally, it is my pleasure to introduce you to Dr. Roberto Lucchini. Dr. Roberto Lucchini received his medical degree from the University of Brescia, Italy in 1987. He obtained his certification of specialization, a board certification in occupational medicine from the University of Parma, Italy. He served as medical doctor and professor of occupational medicine at the University of Brescia, Italy. Then, from January 2012 to June 2020, he was the director of the Division of Occupational and Environmental Medicine at the ICOH School of Medicine at Mount Sinai in New York. Dr. Roberto Lucchini was also the director of the World Trade Center Data Center at Mount Sinai and the director of the NIOSH-founded Education and Research Center for the states of New York and New Jersey. In these capacities, he coordinated the epidemiological health surveillance of the workers involved in the cleanup operations after 9 September event. He also supervised the training and research programs within the ERC network, which includes Rutgers University, NYU, and the New Jersey Institute of Technology. Since 2020, Dr. Lucchini is a professor in the Department of Environmental Health Science at the School of Public Health, Florida International University, and director of the um, NIEHS funded training in environmental neuroscience T32 program. He also maintains an affiliation with the University of Modena and Reggio Emilia, Italy. I had the great opportunity to meet Dr. Roberto Lucchini back in 2015 at the Summer School of Occupational Medicine in Brescia, Italy. So it is my pleasure to welcome you, Dr. Roberto Lucchini.
Thank you very much, Norville, and it's really a pleasure to reconnect with you after after some years. And let me know if you can see if I'm sharing my screen correctly.
Yes, it's working. It's working.
Okay, so thank you very much to all of my colleagues because actually my job is a bit easier because you have heard a lot of important information before my presentation. So let me see if I can find a pointer here, probably. Okay.
Mm.
Okay, so let me say something here because my presentation, differently from Dr. Aldo, who just gave a presentation from the perspective of a field of a doctor in the field. I think that is absolutely important. I am here to see this in the perspective of research, as similarly to Barbara, who presented earlier on the night shifts, etc. So research is important as well when we talk about biomarkers, because what we do in research, of course, in scientific approach, we have more freedom, and we have to do it in this way. Rules and regulation, okay, but we have to sort of look into the science because what we do in research then is very important because then it can be eventually applied into practice. So research, don't underestimate the need for research. I think that I'm repeating what my colleagues already said, the need for more understanding, deeper knowledge, etc. So, okay, I divided my presentation in three parts, of course: exposure biomarkers, biomarkers of effect, and sensitivity, trying to provide some updates on about these three components. So let's start from the exposure biomarkers. So the concept here is to focus on the relation between environmental and biological measurement. So here, this is a classical representation. Okay, so this is kind of 1987, as you can see here, where you can see from the exposure to the disease. Again, you start from here. You have the internal dose, biologically effective dose, early effects, alteration, and disease. So you can have exposure and effect biomarkers into this kind of progression. Hopefully not the progression, but this can happen if we don't do anything. And then we have the susceptibility biomarkers. So we will see something about these three components, okay? Okay, I'm gonna go backward when I was a student many years ago, and I met Norville Antonio as well in Italy. So this is what we're doing. This is a workers, and you can see here, this is personal sampling, this is area sampling. These are pumps basically that suck the air into some membranes, and the membranes then, I apologize if I'm saying something that people know already, but this is a fundamental activity in trying to understand the exposure. Here we're talking about airborne particles. Okay, we are close to the emission here. This is a furnace for steel emission, so there's a lot of particles of metals, of organic compounds, etc. So these pumps are important because they analyze during the shift, basically, personally following in individual workers or placed here as a certain or in other areas to have a complete understanding of what's going on in these components. So of course you can have different selector for the dust, for the particles. So you can select larger particles or other smaller particles. So this is all important to have this kind of assessment. Okay. So here's what I was doing years ago. A lot of, you see that those old slides, we didn't have a lot of computerized help. So there was a lot of manual work here and trying to create this kind of relationship. This was cadmium in the air, you see in micrograms per cubic meter, and this is urinary cadmium. So in this case, classical representation, you have a exposure biomarkers increasing with the increase of the exposure. And also, I noticed this. This was all manual. It's literally, we were doing this stuff like writing notes and put it into the graph, etc. But it was interesting experience to understand. For example, here this is a two different curves. One is workers up to 6 months, so new workers. Hello, I heard something. Is there a question?
Oh, it has already been muted, the microphone.
Okay, so these
Okay.
were new workers, okay, earlier than 6 months. These were kind of older, more experienced workers with more than 6 months of working in the company. So you see, for the same level of urinary cadmium, sorry, for cadmium in the air, these guys they were having higher level of urinary cadmium. So it was interesting to see though in those years the versatility, the whatever all these biomarker of exposure could tell us. I mean, that was very informative to understand what was going on in terms of the exposure. And okay, so, sorry, this is still in Italian, but this is urinary aluminum here, urinary aluminum here and here. This is for dust, and this is for fumes, and this is for dust and fumes in the air. Okay, but this is urinary aluminum for the dust and for the fumes. You see, fumes are smaller particles, so you can inhale more easily these small particles, and the urinary aluminum increases more than when you inhale larger particles. Again, something that the biomarker of exposure were telling us, and so I think it was great to understand all of this. And this is lunedì is Monday, venerdì is Friday, and you can see also looking into the behavior from Monday morning, Monday evening, Monday afternoon, then Friday with some increase during the week, and even after 15 days, some urinary aluminum still remain, and this is the reference group that we're now working with aluminum. So that was the early days. Also for the solvent, you see toluene and epuric acid nicely correlated. Very old slides, I apologize. But I just wanted to go back into history to see where we come from. Because this is still, of course, all of this is still valid. Nothing has changed because these are very traditional but basic concept here about the use of exposure biomarkers. And also, for example, here, this is epuric acid when you are exposed again to toluene, and you can see the timing of exposure is very important. If you collect a urine after 6 or 8 hours, okay, you have the peak of excretion. But if you collect the urine too early, you don't have a lot of epuric acid, the metabolite. If you collect the urine 24 hours later, you have almost nothing. So that's another good information that the biomarkers were telling us. Be careful. You have to collect the sample at the right time. Dr. Aldo, he was talking about toxicokinetics, etc. This is why these are the example of why it was so important to study the behavior of all these exposure biomarkers. So we jump ahead in the years.
Direitinho? Deixa eu ficar você aqui.
Oh, sorry, doctor. I just
Okay, no
moved
problem.
one microphone.
Okay. So we jump ahead in the future and we come to our days. Okay. And what happens today? Today we have multiple media, multiple exposure, exposome, Norville mentioned I heard you. You mentioned the exposome at the beginning. So all this idea of multiple component and the ability that we have to consider all of them. And it's true. It's more realistic, basically, because what I was doing when I was a student, you see, I was considering cadmium or aluminum or this or that one at a time. Nowadays, there's this tendency, obviously, to multiple exposure, exposomic ideas of let's try to understand what happens when we are exposed to different things at the same time. Also because, you know, the analytical in the laboratory, going from atomic absorption spectrometry, for those of you who know the methodology in the lab, that was only one element at a time. Then ICP-MS, obviously, it was a revolution because, you know, multiple analysis of multi-elemental analysis in the same sample at the same time. And moving forward to XRF and all these new techniques that are kind of important advances also in the technology for the measurement of all these things that can change, okay? So the biostatistics models that today are not as manual as what I was doing when I was a student. Now there's sophisticated BKMR, WQS, all these biostatistical models that can incorporate a lot of data at the same time, allowing us to try to understand a little bit more what happens. It becomes more complicated, of course, but this is the challenge. This is the effort of the research to try to understand all this complexity. Okay, so again, back to what we're talking about here. So we have all these environmental media. Also in the workplace, we have airborne particles, we have deposited dust, surfaces, whatever. In the workplace, a lot of surfaces and soil, and also water, and also food. People eat in the workplace, okay? So they shouldn't, but they should be careful, but you know what happens. So there's a combination of inhalation, of dermal absorption, of ingestion. Everything goes into the bloodstream. So we can use the blood, plasma, and serum as biomarkers. And from there, we can go to urine, hair, toenails, fingernails as well, saliva as well, etc. There is one exception, which is very important. The olfactory pathway, airborne particles, especially the small one. Think about the welders, okay? Especially the welders with fumes, very, very small particles through the nose and the olfactory pathway that bypasses all of this, goes directly into the brain. So my kind of interesting research is neurotoxicology. This is why I'm especially, and I'm going to talk more into that kind of direction about the neurotoxicity of the exposure, just to give you an example that also reflects my research experience. So using these kinds of approach here, this is an example about what we did using WQS, weighted quantile regression model. This is one example of this biostatistical models where you put a lot of information at the same time into the model to assess. In this case, we have manganese, lead, chromium, and copper measured at the same time in air, outdoor, indoor dust, and soil. And with a different biomarker, you see blood, hair, nails, saliva, and urine. Because we wanted to, this was an example, to use these kinds of statistical models to understand what biomarkers reflects better the exposure from these different environmental media. What happens here? So we tried to use these models. This is interesting. This is manganese, and you see manganese is nicely reflected by nail manganese, nail, toenails, and fingernails. They're kind of good biomarkers for manganese exposure. And you can see in the literature, there's a lot of studies on welders, okay, using toenails and fingernails as an exposure biomarker that kind of reflect the exposure, not only the current exposure, but also going backwards because the nails take some time to grow. And so therefore they are a good, reflect the exposure quite well. And you can see the model can integrate the information coming from air, indoor dust, outdoor dust, and soil here. And then, for example, lead surprisingly was nicely reflected by saliva and also from blood. Blood is the typical blood lead. Everybody knows blood lead is a typical biomarkers for lead, but also saliva. Not many people are using the saliva. It happened almost for chance for us because we just wanted to try the saliva. But look at this. That was an interesting understanding. Chromium, of course, you have urinary chromium here, but you also have blood chromium, hair and nails reflecting air, indoor and outdoor dust, and copper, saliva as well. So these are examples of what we can do today using this type of whatever we want to call them, but statistical models that can incorporate a lot of information at the same time. And I sort of look at the nails. Look at the nails. This is interesting because there's a lot of studies using nails as a biomarkers. Okay, you should wash them. Remember, because there's always a problem of external contamination on especially on nails and hair samples. So you really need to wash the samples very well so that you are make sure you're capturing the endogenous component, not the exogenous, okay? So there's basically here is kind of a nice way to see how you can do this type of assessment, and you can use basically digest your nails, digesting with alkaline or acid, and then look into the HPLC-MS to measure a lot of organic compound in the nails, okay? Or you can digest them with acid, put them into the ICP-MS, and measure your metals. Or you don't digest anything. You just use X-ray fluorescence. You don't need to digest the sample. You just use X-ray, okay? And you have the detector, and you do the metal analysis like this. So you see, this is very nice advancement. Again, this is a very recent, sorry, what did I do? Okay, go back again. So this is a very, very recent review, I mean, just published. And you can see, you can go through this review and see all the studies on nails. And another application, another study, quite recent from my colleagues here. No, sorry. What is this? Okay, so yes, that's the same review. The same review is telling that 261 human biomonitoring studies using nail in the last 10 years, 38% on organic compounds, looking into all these PCBs, PFAS, etc., phthalates, etc., 62% on metals. So it seems like a growing interest and use of nails as a biomarker of exposure. Interesting. This is another recent study here on welders. These welders are in the school of welding. So they did this kind of repeated measurement before they were starting the schools and afterward. And they saw that the repeated measurement was a very important predictor of elevated biomarker levels in hair, and fingernails, toenails for these different metals. So again, there's also this good concept of doing repeated measurement for the biomarker, because only one measurement is okay, better than nothing, but it's always good to have repeated measurement to have a better understanding of what happened. So this is a very nice studies. If you want to take a look at this, is also quite informative about all these individual metals, how they behave with these different types of biomarkers. Here you have also hair, okay, that was considered into the study. Okay, so now this is another experiment that we did. We wanted to assess something using our biomarkers, because we know something here. Different biomarker media represent different aspects of each chemical toxicokinetic, okay? So no single medium can fully capture the toxicokinetic profile for all the chemicals in a mixture. So basically, what can we do here? Here's the idea, a potential solution. Combine the exposure biomarkers, okay, different ones, to integrate all of them into something that is kind of a multimedia biomarker approach. So let's put them all together, okay, and see what our statistical models can tell us when we do this. It's the same idea, okay, that is kind of a, I guess it's a general trend to incorporate information at the same time. Also in this case. So here is like, you see, you have all these hair, urine, blood, and therefore lead. And for manganese, you use all of them together and see this was like what they do to cognition, the IQ, etc., to see what happens to that into that kind of neurotoxicity. So you combine all these biomarkers together and you create some integrated, you see blood, urine and hair and nail and saliva lead, blood and urine, hair and nail and saliva manganese, and you create this multimedia biomarker for lead and multimedia biomarker for manganese. So somebody could say, what is this? This is violating the toxicological classical rules. That's okay, but we are in this research that we are experimenting, okay? So we are trying to understand what happens if we do this. And it's interesting because as you see here, the MMB, the multimedia biomarker, was kind of more significantly related to, as a beta coefficient, to the cognitive impact in this case. It was saliva as well as an integrated biomarker of lead and manganese, but these other not that well. So the most relevant was this multimedia biomarker. And within the multimedia biomarker, you can differentiate the contribution of each one of them. Obviously, for blood, you can see that lead is very, very important because we know that blood lead is highly relevant in reflecting lead exposure, but blood manganese is not as good as blood lead, sorry. So this is some type of new trends in research again, for the exposure biomarker. Okay, now let's look at the effect biomarkers. Effect biomarkers, we get into the some differences in terms of measuring proteins or something that can be the effect of the exposure. So here's a study that we have done on manganese workers. These are workers that are now more than 50 years old, okay? They have worked for many years in the ferroalloy industries, steel industry, so they experience many years of exposure. And we have done a lot of work with them in terms of assessing motor function, cognitive, because we know the neurotoxicity of manganese, of lead, and other metals in those exposure. So now that they are kind of older, we wanted to check this. This is beta amyloid. Okay, so because beta amyloid is a biomarker that can be have some prediction of cognitive impact and dementia. Okay, they don't have dementia, but obviously, as we heard before from Dr. Aldo, this is important to assess the early signs of something because we don't want to see the progression of the disease. So obviously, this is kind of technological assessment of the PET scan that can show us the beta amyloid deposition in the brain. This beta amyloid is a protein that can actually, because of the exposure to metals and other chemicals, or because of genetic susceptibility, etc. We don't know exactly, but there's a change in the configuration of these proteins and other proteins that aggregates into the brain, and post-mortem you can see those plaques. Okay, so in these workers, basically the PET scan is reflecting that the position of beta amyloid that is forming those aggregates. They don't have dementia, of course, but there is that sign. And this is, of course, a PET scan overimposed on the MRI as a kind of a technological aspect here. But these are the exposed workers compared to their historical controls. Okay, so what have we done with these workers? It's a small study. because the PET
Yo nomás
scan.
sabes ahorita lo que los predoctorales de inglés. No tengo idea. No,
Puedes.
pues es. Puede que,
Can you mute?
Yes, we are muting them.
Okay, I'm
Sorry.
almost finished. Don't worry. So this is, you can see here the proteomics. We can use the proteomics as effect biomarkers. These are all proteins, and you see them. They are basically different between workers and their controls. And these proteins are, you see, again, this is like a beta amyloid again, and other proteins that are related to the brain functionality, let's say. And it's important to see all of them kind of more increased in the exposed versus the controls. And here we have plasma manganese kind of different between the two groups, and with some dose response that is telling us, look, here you have effect biomarkers, different ones, and are given by proteomics, okay? This ratio, A beta 42, A beta 40, is a predictor of cognitive impact and dementia. And you see here, and the total tau is another of these proteins that are, can aggregate in the brain. So these are effect biomarkers that can possibly predict something like that. We have done metabolomic also in addition to proteomic. And again, metabolomic is another way of measuring effect biomarkers, right? Into the metabolites, a lot of metabolites, and we see how do they change between exposed and controls, and they do. And then we do some, sorry, the kind of complicated volcano plot, but it's basically some of those metabolites increase, some of those metabolites decrease, but with significant differences between exposed and their historic control. So this is another kind of how can I say, another example of effect biomarkers that we are adding here. And also, when you do this analysis of the biomarkers, you can try to understand what are you, what are they telling us? These biomarkers, sorry, these metabolites are related to what? What type of function? And so you can do all this type of pathway analysis and enrich metabolite sets, and you can identify the metabolites that are more important. And then you try to understand what are these metabolites for? What type of function? And it's interesting to do all this process because in this case, all these metabolites, they were related to function that are kind of related to what we have seen with the beta amyloid. So it's kind of a coherent picture here that comes out of all these different angles that we're trying to put together. And interestingly, with some dose response relationship. So it seems to be pushed by the exposure that can trigger the proteomic, can trigger differences in metabolomics, and also in this, of course, brain imaging alteration. So the last part, and I'm going to stop, susceptibility biomarker. So these, we're talking about the SNPs, and I really appreciate the comment from the Brazilian worker, a colleague that said, what about the the ethical aspect of this coming into the genetic part? Well, in research, we don't have that concern. Of course, we need ethical approval, but we are not in the workplace. Okay, so we don't have that problem, but obviously we have to consider that as well. But we need to do this. We need to do this because it's something that is real. So this is another example related to what I do, obviously, but this is an example that you can transfer to other types of exposure, etc. So these are transporter genes, SLC30, SLC39. They were discovered quite recently because they discover basically a genetic disease due to the completely homozygous mutation of this transporter gene. When you have a homozygon mutation, that means that those genes are not producing the enzyme that are needed to regulate the transport, okay, of something. In this case, it's the transport of manganese and zinc and maybe other elements, but these children, because of course you have a genetic disease when they are born, they are born with this zero transporter, unfortunately, and they are born with these symptoms: Parkinsonism, high manganese, polycythemia, and chronic disease. These are kind of something related to that homozygous mutation. Homozygous mutation is very rare, of course. Fortunately, it's very rare. But the non-homozygous is not that rare, okay? It's present in the population. And if you go on the internet in this historical 1000 genome project, you can see the frequency of this kind of mutation in Africa, in America, in South America, in Asia, in Europe, etc. And this is all important information because you want to know, in my population, in Peru, in Argentina, in whatever, in Italy, or I don't know, do I have this non-homozygous mutation? I want to know because if they're there, they could represent some hypersensitivity biomarkers that could put somebody at risk, okay? And if you explore this data in this project, you can see this is Peru, this is Puerto Rico, this is okay. So you see different location, you have different prevalence, different frequency. It can be different percentage of the population. It can be 10%, 12%, or 20%, depending on the ancestral, whatever origin and the geographical distribution. But you can have some of the population, some of the workers, 10, 12, I don't know, maybe 20% with some homozygous alteration. Perfectly healthy, but more at risk because in this case, their transporter is not working perfectly, not working 100%. So we have done this comparing cohorts in Bangladesh, in the Andes, in Argentina, and in Italy, and you can see that they increase blood manganese or reduce blood manganese, different alleles, independently from the geographical areas of the planet. So this is really something that can be an important component to consider in terms of biomarkers. And this is another way to see how the genetic configuration can influence the dose response, okay? Because you go from blood manganese impacting neurotoxicological impacts, and you see that this relationship, the dose response, is influenced by the different genetics configuration of the population that you are studying. So the SNPs can tell you, look, there's a 10%, 12%, 15% of your workers that are more vulnerable because their transportant doesn't work exactly at 100% as the others. So if you don't know this, you don't know it. But if you study also the genetics and the biomarkers of hypersusceptibility, you can capture their role into this, okay? I thank you, everybody. Here's the acknowledgement of all the students and colleagues at Florida International University, University of Georgia, Arizona State University, New York, Brescia, Italy, and the grants from NIHS. Thank you very much, everybody, and I'm here to answer any question.
Thank you, Dr. Roberto. Thank you, Dr. Roberto. It was a great presentation, and we are really happy to have you here to solve some questions. So please, any of the attendees that would like to make questions to Dr. Roberto, there are some Spanish speakers and English and Italian speakers, so feel free to make any question in language that you feel comfortable. If you are more comfortable making questions in the chat, we can also read the questions to Dr. Roberto, and we can help with the translation. But Dr. Roberto can speak Italian Italian, Spanish, or English. So, Dr. Roberto, there's a question from Dr. Bruna Cuadros. Would it be ethical to make it slower the limit of action to a wider approach of the population that is susceptible uh, to this type of transportators?
Oh, very good question. Very good question, Bruna. You know what? I think this is a question for the agencies that work on these policies. Basically, the, they decide. You know, I think I don't know, Ilius or some other entity doing this type of Ministry of Labor. Okay, so it can be EPA, it can be Europe, it can, so I guess that what I know because I've been working with entities that during this big, they always say that they need data. Put it like this, because when they have to decide about the standard or the exposure limit, of course, if there is science, good science there that they can rely on, of course they have to consider that. If not, if there's no or very few data, they cannot. So this is again, this is why at the beginning I said research and science is so important here, because also for that purpose, I mean, it's very important that as scientists, basically, we produce, if you want, produce more evidence, more science, more data, so the regulator can have more information and can decide more accurately about the protective levels, of course, because maybe there's some evidence about some type of genetic influence or susceptibility biomarker that is supported by evidence, so that they have to consider, and they consider it. But if not, it's very difficult. One study, two studies, that may be not enough. So this is why it's very important to continue with our work and try to support what we do and collaborate at any level. Because you've seen, I mean, if you look into the geographical data, this is very interesting. There are parts of the world where the genetics can be different, okay? And so it's also important to look also at your specific region, and because things can change from Europe to Latin America, etc., or Africa or Asia. So it's important because it's not always the same. So we need also local studies, I think, not only, in different parts to come out with something that can unify. In our example, we put together Italians, what was it? Bangladesh and Argentinian Andes, because in the Andes of Argentina there's some type of metals exposure. So we wanted to use very different population in the same study, just to see whether we could be able to reach the same conclusion in terms of the genetic influence on this. And we saw that it was almost identical, regardless from the geographical differences.
Thank you, Dr. Roberto. From the Scientific Committee of Working Time and Shift Work and the Working Time Society, we have Dr. Frida Fischer, who is asking the question, did you evaluate those response differences between day and night workers, taking into account those exposure to metals?
Hi, Frida. Thank you very much for your question. Yes, we have so many data because we are following these workers. Believe me, since when I was a student, so that's a long time. And of course, there's a lot of shift work in the steel production, etc. You can imagine they do terrible shifts, because somebody before asked about what type of night shift, regular, unregular, total craziness about the type of shift work. But we didn't really see a lot of a lot of differences of influences into these different types of shifts. And but again, it also depends because maybe we were not really exploring what Barbara considered in her presentation. We are looking into the proteomic or the metabolomic that may be affected by the shift. I'm not sure. That could be also, but in our initial analysis, it didn't look like. But of course, it's a good point. Thank you.
Okay, we have one more question from Dr. Ricardo Alvarado.
Cifras estandarizadas para identificar. No entiendo la pregunta. Disculpa, Ricardo. Muestra para los multimarcadores.
He's asking that if there are some standards that we
Okay, okay,
can
okay.
check. Mhm.
Very good point, Ricardo. Okay. So this is a very important point because I had this conversation with a colleague from EPA, for example, because I want to know from their perspective, are they consider the mixed exposure, the exposomic approach or not? And he basically said, for now, no, because it's way complicated for us to regulate the mixture. This is what the answer. And I think it's understandable because it's quite complicated. You can imagine the combination of mixture are enormous possibilities. So that's going to be quite difficult to think about protection from mixture effects. And the mixture effect is something that can happen when, I mean, I've seen this because if you consider the effect of one component, okay, separately from the other, they could be a very low level of exposure. But when you put them all together, because of the interaction between them, you can see the mixture effect. And that you cannot appreciate the effect of the mixture if you don't have the tools to look into it, you know? So it's an important conversation here. I think nobody has a real answer at the moment, but this is definitely something quite important for the future development because I see that with all this big data and all this science and machine learning, artificial intelligence, and all that, this is a trend. This is a trend from the classical toxicological approach of when I was a student to the present and the future. This is clearly a trend because of powerful computer, powerful processor, etc., etc., etc. You will see more and more of this dynamic of putting things together, etc. How to understand this complexity and how to regulate it, this is a very challenging part. And but this is obviously the EPA colleagues. He said that this is in their agenda. Obviously, now with this situation in the United States, I don't know what's going. It's a little bit not usual, let's say. But this is in the agenda because, of course. It's an important concept to deal with because you will have more and more studies producing this type of mixed exposure, multiple component, etc. And of course, the scientific evidence will grow for sure. The decision makers, they will receive all these studies and they have to consider that somehow. So, good question. Thank you.
Is anybody else that would like to make a question, please? So, Dr. Roberto Lucchini, thank you so much for your participation here, for sharing with us part of your experience and research. And to all the attendees, also thank you for sharing your time here and for being so active with the questions to our speakers. We are going to share with you the recordings of this webinar. So we have left a link uh, in the chat so you can put all your information there, especially your email, so we can send it to you when it's ready. So thank you, Dr. Roberto. Thank you all, and we are going to keep in communication. We would like to invite you to the future academic events and webinars that we're going to organize from the National Secretary of Peru. So have a good afternoon or night or morning, and wherever you are in around the world, because we have been talking with people from different countries. Thank you.
Thank you, Norville. Thank you very much, everybody.
You're welcome, doctor. Thank you. Para los hablantes en español, recordemos que acá tenemos el enlace en el chat para que por favor puedan registrar su asistencia y que podamos compartir las grabaciones también de las presentaciones. Sí, acabamos de enviar el enlace nuevamente por el chat para que puedan registrarse. We have already sent a link by chat, so you can fulfill your information in the form. Just in case that this link doesn't work, I am leaving my email, so you can contact me directly too. Acabo de dejar también mi correo en caso que no funcione el enlace para que puedan enviármelo también directamente.
Sí funciona el enlace Norville. Gracias.
Hola Álvaro, muchas gracias. Un gusto saludarte. Saludos para Guatemala también.
Gracias, muy amable. Excelente actividad. Felicitaciones.
Gracias a todos.
Muchas gracias a todos. Feliz tarde. Un abrazo desde Colombia. Cuídense mucho.
Muchas gracias, doctora Diana, y a todos los colegas de Colombia. Bienvenidos
Gracias.
siempre. Gracias, doctor Lionel, doctora Ana María, doctora Bruna. Muito obrigado. Doctor Reinaldo, doctora Miriam, gracias. Y compartiremos las presentaciones con todos. Es importante que registren su participación y su correo, sobre todo en el enlace que estamos enviando. Gracias, doctor Alejandro, y a todos los colegas también de México. Gracias, doctora Corina. Y compartan por favor el enlace con quienes ya se retiraron, pero que saben que estuvieron conectados para que puedan registrar sus datos. Buenas tardes con todos. Thank you, Dr. Roberto, and hope to see you again